Alright, so as promised, I'm going to solve this same question, number 63. This is on page 544 of your textbook. I'm going to solve it without using the voltage loop, or I guess the loop rule and the junction rule. I'm going to simply, to the best of my ability, try to solve it with knowledge that I have about physics and circuits here. So, hopefully my voice doesn't crack like that throughout the whole video. I know that the source of the battery is 15 volts. I also know that each parallel loop receives 15 volts, and if I cancel or basically if I add those up, they cancel each other out, so you get 0 volts in the loop. So this is going to be 15 volts through this top branch, 15 volts to this bottom branch. I also know that resistor 1 and resistor 2 have the same resistance based on the given information, and that current 1 is going through both resistors, and that current's going to be the same. So essentially what that means is the voltage has to be the same across both of these, and if that's the case and there's 2 of them, then simply 15 divided by 2. So I'm going to say voltage 1 is 7.5 volts, voltage 2 is 7.5 volts. The next part, I'm going to look at the current situation. Let's see. The current that's going to go, this current here, I3, that's going to go through those 2 resistors, has to equal times the resistance, so I3 times R3 plus I3 times R4, has to give me 15 volts. If you recall from Ohm's law, current times resistance is voltage. So the voltage at this point and the voltage at this point added together has to give me 15 volts. So if I just write that out as I3 R3 plus I3 R4 equals 15 volts. And these values here, R3 and R4, were given to us as 150 ohms for R3. So essentially I'm looking at 150 ohms times I3 plus 200 ohms times I3 equals 15 volts. I'm going to do a little math here and see that 350 ohms times I3 equals 15 volts. So solving for that last line, I had 350 ohms times I3 equaled 15 volts. If I divide both sides by 350, divide by 350, I can keep the ohms here, cancels this out. I3 is equal to 0.04 amps. I also know that all of my current at this point right here, current from the source, is split into I1 and I3. And I1 was given to us as 4 ohms, so if I look at I at the source, I1 was given to us as not ohms, amps, plus I3, which we just discovered is 0.04 amps. Altogether, it gives me a current of 4.04 amps for current at the source. That being said, I also know what the voltage is at the source. I know what the current is at the source. Just discover that to be 4.04 amps. The resistance at the source is just Ohm's law, where resistance is equal to voltage divided by current. Do a calculation here, that gives me 3.71 ohms. Solving for the individual resistors now, I know that the overall formula for a parallel circuit looks like this. 1 over RT equals 1 over R1 plus 1 over R2, so on and so forth. In this case, because my resistors in the first branch are in series with each other, I'm going to find a sum of those two together, and that's going to be my first component of 1 over. So 1 over R1 plus R2 plus 1 over R3 and R4 for the second branch of the parallel component of my circuit. For R3 and R4, we have values that were given to us. RT we just solved for, so if I just plug those numbers in to see what that looks like, it's like this: 1 over 3.71 ohms equals 1 over, if you recall, R1 is equal to R2, and that was given to us in the question as well, right here, R1 equals R2. So I can simply say that this is going to be 1 over 2 times R1 plus 1 over R3 is 150, R4 is 200, 350 ohms. And then need to work on isolating the 1 over 2 times R1. So I'm going to bring my 1 over 350 ohms to the other side of the equal sign, so it'll become a negative. I'm also at this point going to start working with decimals because I don't want to find a common denominator between 3.71 and 350. So I have 0.2695. This is over resistance. I'm keeping my unit of resistance underneath in a denominator. That'll make sense because my resistance here is also in the denominator. Then I bring my 1 over 350 over. That becomes a negative 0.0029 per ohm equals 1 over 2 times R1. To get rid of this 2, I need to multiply this side of the equal sign by 2, and I need to multiply this whole thing here by 2 as well. That's going to give me 0.5332 per ohm equals 1 over R1. If I do a little cross multiplication, I'm going to realize here that R1 equals 1.875 ohms. And because of the given in the question, R1 is equal to R2, this is also equal to R2 value. All right, so far, to recap what we've calculated, just with our basic knowledge of circuits here, I calculated that I3 was equal to 0.04 amps. Calculated that R1 being equal to R2 was equal to 1.875 ohms. V1 being equal to V2 was equal to 7.5 volts. And though it's not asked of us in the question, I'd also like to find the voltage at position R3 and position R4 here. So let's just do that very quickly using Ohm's law. I know that V3, or position 3, is going to equal I3 times resistance 3. I3 we know is 0.04 amps times 150 ohms. That gives us a value of roughly 6.4 volts. For voltage 4 at resistor 4, current times the resistance value, again 0.04 amps times 200 ohms, I get a value of 8.6 volts. And this here should make sense. If I add this 6.4, 8.6 together, I get 15 volts. And again, that's exactly what my voltage needs to be in each branch of a parallel loop because my voltage at the source was 15 volts. And there you have it. That's method 2 without using the loop rule and the junction rule to solve for the same question. Once again, if you look at the back of the textbook, you'll see that the answers they come up with are different. And I challenged you in the last video to work through using their numbers to see exactly why those numbers are incorrect. And they actually don't make sense in terms of resistance 1 and resistance 2 and total resistance. So hope you enjoyed this video. We'll see you in the next one.